All right, here we are again, algebra guys. We're moving on. Brand new chapter, solving systems of equations. This is kind of interesting because we want to see what happens when when equations collide, right? A system of equations is two or more equations with the same variables, which means for our terms in this class, x and y. All right. And we like that because x is our input and y is our output, so we like to be able to graph like that. You can do it a couple of ways. You can solve a system by graphing it, like creating a table and graph the equations and see where they intersect, or if they're parallel, or if they're the exact same line if you solve it and the input and outputs are exactly the same. And they all have different names, and I'm going to show you these names shortly. There they are. Okay. So if lines intersect, right, I'm going to blow this up just a little bit just so you can see it and pull it. Oh gosh, there it is. So if the lines intersect, that means they have different slopes. It means they've been going at different rates, and they could be, both going up, but one goes up at a steeper rate than the other one. Or they could be going down and one goes down at a steeper rate, or one up and one down, yada, yada, yada. I say that just so that I can go here. They have different slopes and they have weird classifications. Oh my God, weird classifications and weird numbers of solutions, right? The classification is consistent and independent. And if you think about it this way, these are two independent lines that have one solution. So they are consistent and they do have one solution. All right? Consistent means they come together. Independent means they have one independent solution. Okay? So the next thing is, if they are the same line, or the lines coincide, they exist on the same line with each other, you solve it and it comes out to be the exact same equation. Then they have the same slope and the same y-intercept, and they are also consistent because they come together, and they are dependent on one another, right? And that means they have infinite solutions. The last one is, if lines are parallel, that means they have the same slope and they never come together. Right? They have the same slope but different y-intercepts. That means they're inconsistent and they don't intersect at all. So there's no solution to this system of equations. Now, here we go. Here's the fun part. How do we do this, sir? Right? You keep telling me all these fun things about mathematics, but you can't tell me how to do this, right? Well, here we go. We're given a system of equations. The first equation in standard form is x minus 3y equals 6. And the second is 2x minus y equals negative 3. Step 1. Well, step 2 to me, but step 1 is rewrite these things in slope-intercept form. Well, here you go. We can rewrite this in slope-intercept form by subtracting x from both sides and dividing everything by negative 3, which would be y equals 1/3 x minus 2. We'll do some on our own so we can get the steps going. I'm just telling you about it now. This one, subtract 2x. Divide by negative 1, we end up with y equals 2x plus 3. Now we have two different equations. We can graph these two equations, right? Well, there we go. This one is obviously 1/3 x minus 2 because it crosses the y-axis at negative 2 and has a pretty shallow slope. This one has a steeper slope and crosses the y-axis at 3. And when you create those lines, they intersect right here at negative 3, negative 3. And you would say that the solution to this system of equations is negative 3, negative 3. it is consistent, right? And independent because it only has the one solution. All right. Let's do some graphing, kids. I know you love this. I'm actually going to make it bigger and do this first one so I have space to rewrite these equations. The first thing I want to do is what? That's right, put them both in slope-intercept form. So what am I going to do? I'm going to subtract 3x from both sides. So I'm going to end up with y equals negative 3x minus 2. I'm finished. I don't have to do any division, so I'm good. My y is good. So the next thing I'm going to do is fix this one. So now we have 2y equals, subtract 6x from both sides, minus 6x, plus 10. Well, I got a 2y here. I only want 1, so I'm going to divide everything by 2. Divide everything by 2. Did you hear that? I think I said it loud enough, right? Okay. So divide that by 2, we get y. Negative 6 divided by 2 is negative 3x. Oh my gosh. Look at that. They have the same slope. We'll get to that in a minute. Plus 5. Yikes. I'm going to have to go by 2s. 2, 4, 6, 8. See? Got a y-intercept of 5. Down 3 over 1. Down 3 over 1. So I've just graphed this guy. That's this guy right here. What about this guy up here? It starts at negative 2. And I go down 3 and over 1. And down 3 and over 1. Wait a minute, sir. These guys have the same slope, so they never meet. They're parallel lines, sir. They never touch. Have the same slope, right? They never meet. They're inconsistent. That's it. That's all you have to do with this part. I'll get back on a little bit later. I'll create another video that shows you how to solve systems of equations by going ahead and doing it algebraically. This one is going to be substitution. It's the one you don't like. That's the way it's going to have to be.